Hello everybody, and welcome to the webinar Complex Requirements in Planning. The agenda for today. At first, I would like to speak about the complex planning requirements. Then I would like to point out the different planning strategies which exist. And then I give you an overview over the tech-oriented planning. That's not only an IT tool, it's more an planning philosophy, and I would like to introduce it and also would like to show you the best basic principles of this planning methodology. And last but not least, I would like to point you to our additional webinars. Complex requirements in planning. What are these requirements? At first, we have the three classic goals of planning. We will speak about transparency, about meeting deadlines, and about efficiency. And the idea of a classic planning tool is transparency helps us to meet our schedule and our dates. And if we meet our dates, this brings us efficiency in the production. And when we ask our customers, why do your customers buy from you? They say, of course, of the short delivery time and a high reliability of our delivery dates. They speak about the pricing and about the quality. 20 years ago, quality was the top priority, but now, today, the logistic goals are the main priority. Let's go a little bit deeper in this planning. Customers buy because of the high quality, but when we see Germany, I think it's a precondition because we have high labor costs, and even other companies in China produce now machines and whatever in a decent quality. So let's have a look on schedule. The customers say, I buy from you because you have the shortest delivery time and a good quality. But the shorter the delivery time, the more difficult is it to guarantee this delivery date. So date changes and other things, machine breakdowns, mix up the whole production plan. So it's quite difficult to manage and to guarantee always a short delivery time. But on the other hand, customers want a permanent and reliable delivery time. They don't ask about internal problems. They want to have reliable dates. And of course, planning against these dates is a prerequisite for delivery in time, and transparency over the whole production process enables a timely reaction to disruptions. When we see efficiency, efficiency is very close to the reason a low price, because a low price requires an efficient production, and an efficient production allows a low price. That's vice versa. And transparency on capacity utilization increases the efficiency potential. So now we have some typical problems in the planning. I think it's like a mountain, ice mountain. Normally we just see the peak, and the production planner has to work with some parameters. He has the inventory, he has the information about the capacity, the available capacity, he has information about the lead time, comes from routing plans and routing information, and he has a couple of planning parameters from the ERP system. These planning parameters are the stock, the capacity, the lead time, and minimum stock quantity, maximum stock quantity, different kind of reorder policies, and so on. But under the waterline, there are the real problems. So he has to deal with incorrect bill of materials that cause wrong inventory. The dates will often be changed by the customer, or other departments are not able to meet their dates. Rework is not considered enough. Absences of employees, unexpected machine breakdowns, and of course, very popular, the quick shots we have, and this all disrupts the production. Normally, the planner reacts on this unpredictable thing, releasing the orders as soon as possible, because he thought, when I release the order as soon as possible, then it's safe and everybody will take care about my production order. He works with buffer times. So to avoid that material is not right in time on the machine, he works with buffer time, and he thinks with the buffer time, other departments have enough time to make sure that the material is there. He changes production lots on his own authority because he says, normally I have to produce 5, but if I produce 10, then my production runs smoother and I have a better output. Or he says, because from performance reasons, if I have a couple of production orders, he takes care on his, let's say, favorite parts, because his favorite parts are the parts where he can achieve a better output and a better efficiency. So on the top, we have that what we see, and under the waterline, there are a lot of unexpected and unpredictable things. But overall, goals can only be realized with a permanent transparency of the processes. And of course, it's important to go away from Excel and to have all data in access. So let's have a look on the different planning strategies. Well known is, of course, the standard ERP planning. On the right side in the diagram, you see 3 production orders on 3 different work centers. Blue or dark are the work time, so setup time and runtime, and gray is the wait time or the transport time, so the not productive time. The classical ERP planning, from my point of view, it's a planning that is none. So normally capacities will not considered because the system plans against unlimited capacity. Now you can say, of course, my ERP system has the possibility to plan against limited capacity. But to be honest, if you try it, it works a little bit poor. And this is the reason why other planning tools come up in the 80s or 90s. So it's a planning far away from the reality. Mostly every ERP system allows a scheduling into the past, what is not possible. It makes no sense if the system tells you you've had to order the parts 1 week ago to start right in time yesterday. So it makes no sense. So it's a planning against an empty factory. And the result is that all production departments work with shadow systems like Excel and so on to make a decent production planning for their department. Dates are not reliable, and overall there is no acceptance to the employees, and it causes again shadow systems like Access, Excel, and so on. Then, as I said, in the 80s or 90s, production planning systems came up. APS, Advanced Planning and Scheduling System, Production Control System, and they try to predict the future. It is a real detailed planning approach. It is a centralized graphical planning with the possibility to optimize and search for alternatives if something went wrong. In the background, there's an algorithm, a high mathematical algorithm, and this causes that we have a black box optimization because nobody is able to understand what happens in the background and what is the result, and nobody can explain the result. And if you ask a consultant for one of the systems, they're even mostly not able to explain what is the result or why did the system make a proposal for this production planning. It is a minute by minute scheduling, and if there is just one small thing in the production, it disturbs the production and it requires a complete rescheduling. There's no room for maneuver, so nobody in the system from the worker on the shop floor can make changes by himself, and there is no acceptance because he has no influence on the production planning. If the problem came up, he gives the problem back to the production planning and say, hey, it's up to you, please solve my problem. Based on this, we developed another planning approach, and it's a tact-oriented planning. Here we say better roughly right than exactly wrong. We are planning in time slots, and it's possible to have only a rough representation about resources and work plans, not so detailed. And two main topics is we have a centralized rough planning and a decentralized detailed planning here. So this allows each guy in the production enough room for maneuver. We have transparency, we bring flow in the production process. We have less effort with the planning and a high acceptance and a feasible production plan. So here we are planning against defined capacity limits, but it is not a gapless schedule, as you can see here. The first routing ends here, and the next production, the assembly, starts here. So of course we have a gap of a few minutes or a few hours. The idea is we plan everything in the stack, and all three orders have for the housing production this delivery date. Now people say, okay, we have, but doesn't it increase the lead time for my production order? If I see here, yes, if I would start with the assembly department right after the housing and with the delivery right after the assembly, then of course I can achieve a shorter delivery time exactly for this order. But in reality, we don't plan against an empty factory. We are planning against a factory with hundreds of orders, and if all want to be scheduled without any gap, this means it's like on the motorway. It's crowded and nobody will reach the goal in time. So here, of course, we have a longer delivery time for each order, but reliable delivery dates internally and externally. If you compare with the APS planning, here we have 3 orders in the system, but we have 9 dates to consider. And if I change something here, it has immediately an effect on the other dates of this production order. In the tact-oriented planning, I have enough room for maneuver. So if the guy in the shop floor decide to start with this order first, and then with this, and then with that order, because that fits best to his to his production philosophy, it is okay for us until he guarantees that all 3 orders will be finished in this point of time. So let's go a little bit deeper in the tact-oriented planning. What is it? So at the end, it is a production system for the discrete manufacturing. So workshop manufacturer, variant manufacturing companies, and so on. And it is a cross-industry project planning system. So it works for production companies and also for project-oriented companies. And it combines all elements of the production planning, like the organization, the responsibilities, rules, resource, capacities, etc., into a dedicated unit in the system, the CC task-oriented planning. And it is more than just only a production planning system. It is a special philosophy here. And it enables the synchronization of all areas of the production and of all capacity in a whole organization. And it brings transparency to the typical goals, meeting the deadlines and efficiency. If we see here, all employees will work in one system, no matter what the task or the role in the company is. So we have here some examples from the order management. So this is a typical centralized planning, and here's all production orders at a glance. We have the real-time planning for the salespeople. If there is a quick short order, they can do the production planning directly and can start check out what is the first possible and really feasible delivery date. We have a view of the capacity management. For the management, we have information about the long-term capacity planning. Does it make sense to hire new employees or to increase the capacity with different options? I have my decentralized detail planning. And of course, I have a shop floor management system where I give key performance indicators for the people in the shop floor that they can make the decision for the detailed planning on their own. Now we have looked at the basic principles of the tact-oriented planning. So what we are doing is we are doing a planning in fixed time grids. That is what we called the resource tact. Like you can see here, we have for on one capacity, tact 1, tact 2, tact 3. And when we are here finished with all orders, we bring them to the next tact and then to the other one, and also the possibility to skip a tact in one production if it is not possible. So this gives the guys on the shop floor the room for maneuver and for processing and for handle the work. We define together feasible capacity limits, that is the tact for each department, and we define a degree of flow throughout the entire value chain. So we define that we have really a smooth flow of the production order through the production. And we make a coarsening of the planning. So we don't do a detailed planning based on machine center, persons, and whatever. The planning is on resource group and teams and machine groups. And we trust that they can manage their work inside the team or the resource group. This all brings stableness to the planning and acceptance to the guys on the shop floor because they are responsible for their own production planning. So here we have a view on the flexible capacity model. It's very simple. It's like a traffic light module. The green area on the left is what we can normally do. So I say I have 3 people in my production area and they work 8 hours per day. So I have a capacity limit of 24 hours a day. And without any problems, I can load work in this tact until the 24 limit is done, is full. Then I have a small area between green and yellow. This is what I can organize by myself inside this team. This is if I spend 1 hour overwork or make an additional shift or whatever. That's what I can do and decide inside the team. So that means for the production planning, if there is there's a peak in the production, normally I plan everything up to the green level, but in some cases I have no problem to go up to the yellow level. It is not the standard, but it is possible. And of course, I define a red area, and I should never plan over the red area because this is a total overload, and then I have to escalate this to their management. And here, of course, we say about rough planning, central rough planning. So plan everything until the defined capacity limit. And in the decentralized planning, they organize what they want to do. So they make a decision which is the first order. They define the sequence of the order. They define the priority of the orders. They define on which machine an order will be produced and so on. And fast and efficient control cycles will be installed. That means if a problem pops up and I come to my yellow or to my over my yellow level, then I go back with a loop to the production planning and we install a communication loops here. And we are focusing on the shop floor management, and this means we're focusing on the problems and not on the normal production planning. So here we have a typical cycle for this. Here we are on the planning level. This means I have my tacts with a capacity limit. This brings transparency to the production planning, and I can define in realistic and fast promise dates. This means I just plan everything until I'm on my green level, and then I can calculate very easily my delivery time. And very important is that I have fixed dates internally and to our customer. So the first department in the production has also a customer, and it is the next department. And he must rely on the dates I deliver. Then I'm in the task list, in the work list. Now I'm the view on the department. I have become a work list, and if I'm in the green area or in my yellow area, the work list is agreed as fixed. I have, of course, a possibility to breathe with my capacity a little bit, so I can use some overwork or whatever. And if I have problems, it's very important that I install a timely and proactive communication. And here I have the decentralized detailed planning. So that means if I decide the sequence of my order. For the people on the machine, it means the date is fixed. They know all tasks in the work list, and the date for all these tasks is fixed. And there is a priority. At first, they focus maybe on a backlog, then on a current act, and then on a next act. And there are predefined escalation mechanisms. So if something went wrong, they know exactly what to do. And at the end of this, each circle is a success control. So after every cycle or tact, there's a control mechanism. We come together and speak about the problems. This means it is a focused leadership work. So the leaders are very important here at this part. We work solution oriented, and we have, of course, support from the management here. Now you can say, hey, that looks a little bit like lean or agile or something like this. And yes, you're right. With the tact-oriented planning, we have the basis so that we can work a little bit like with agile principles in the production. So the tact could be the sprint we have. And we have the full flexibility inside this production tact. So this is Scrum. We can combine it with lean management functionalities like Kanban or no orders released too early. We have methods of the critical chain project management, the CCPM, with the prioritization on dates, no multitasking, harmonized capacities. And of course, the management principles, CONWIP, pull, we work in sequence, and of course, a permanent optimization here. This all is part of the methodology of the tact-oriented planning. Let's have a look on some examples. I said we have a transparency over the entire value chain. Here we have an assembly workplace here, and here we have the graphical view on this. On a glance, I see directly that I have in week 24 some problems here and here. So I have to focus on this. I don't have to focus on these areas, so only on this and this. And I have to make sure that I have an overview of this and I can fix it. And all departments are directly involved in this planning. Here we have also information we deliver. So it means for each production order, all related information like drawing or other stuff can be attached to the production order inside the tact-oriented planning. So we have really here a paperless work, a paperless production. We have workflow mechanism integrated. We have historical data and everybody can use the data. So we see the backlog, we see the actual workload, and we can see the planned workload for next week. So all information are there and are transparent. So the guys at the machine and in the production department can make the decisions on their own. It's no longer part of only one production planner. And let's go a little bit in the white collar area. Here we have a typical example for the engineering department. So it's also possible to include the engineering in the tact-oriented planning. So it's not only, as I said, a production planning system. It helps for the entire order process in a company. So the detailed planning, as I said, it is possible, but it's not strictly required. If I don't have too much orders or the orders are too big, like in the technical department, it makes no sense to make a detailed planning if I have only 2 tasks on my table because I work on each task a couple of days. So here we have, for instance, I can decide it on my own. I have information about my personal usage, so which engineer is working on which order, or if I go back to the shop floor, what is with my machines. I can define a sequence order. I have the detailed planning dates. I can use it, for instance, for picking, and I can do the optimization, and it's a graphical overview, and I know all about this information. Now, I said we can combine it with classical principles like the pull system or Kanban. And what is important is we never push production with CC task-based planning. So nobody push material into production because our goal is to reduce the stock and the work in process. That means I pull everything I need, and this is Kanban. So here we have a picture of a guy in the inventory, and he has on his screen a list of all orders, and he can scan the orders directly from the screen, bring them in an order by call-off date, and create a paper list, a picking slip here. And here we have a picture how it works. So on the shop floor, it's based always on deadlines and realistic planning. We come together after each tag and speak about actual utilization. And we always ask 3 questions. Question A, is there a backlog? And here we consider the capacity and the availability of the capacity. The second question is, will the current tag be finished in time? Yes or no? And then we ask, what is about the future? Will the next 3 tags work smoothly or not? If we speak about these 3 questions and everything is fine, we stop the meeting immediately and go back to work. If not, we ask for actions. Are any actions already initiated or not? If not, actions will be defined. And then we ask, is support needed or can we solve the problems on our own? And if support is needed, the supervisor escalates it to the production planning or to a leader or to the management, and the responsible persons are forced or must support solving this problem immediately. This is the way it works with a task-oriented planning. Here we have an overview over the slides I showed before. It's about management. The management has qualified information. He doesn't have to rely on a APS system with funny results. He has information about the long-term capacity planning, and he can make decisions increasing or decreasing the capacity. And he receives key performance indicators for the whole company. The leadership in the production manager, can focus on the important thing. It's solving conflict situation. And of course, he has also KPIs and information about the medium-term capacity planning. For the sales, there are always also advantages. So information are direct available. One look in a system and he knows when this order will be finished, and he has a reliable delivery date. He can provide the customer with all necessary information. And of course, there's a possibility to make decisions at the project level. So if a follow-up order pops in, he can do a planning about this, and then he can make a decision what order is more important, the new one with a delivery maybe in 6 weeks because there's no capacity, or do I want to scrap an older order in favor of this new one? But he has no more troubleshooting to do, calling in the production, calling with the customer, and handle all the things. The planning can act instead of react. That is very important. Normally, a production planner is hunting the dates and the deadlines. Now he has time to plan something and he doesn't have to run after the plan. And of course, if a plan change, so if I move one order from one tag to another tag, of course it has influence on the other tag, but only for this order and not for the whole production. And of course, he can provide all necessary information for the management, for the sales, and so on. And very important is for the guys on the shop floor is, yes, we are doing this. They all are committed on the goals. They know about the flexibility. They can work smoothly and there is no hectic pace. And they know there's a commitment for all departments on the release dates. What are the benefits of the tech-oriented planning? Of course, it is the base for sustainable success. The precondition is that the logistic must be fit, and of course, we must define a capacity limit, and we have to move everything from the push principle to a pull principle and bring everything to a flow, to a smooth rhythm everybody can follow in production. Then we have to follow the principles. Central rough planning, more decentralized detail planning, and more responsibility for the departments in the production. The principles has to be implemented, and it is a cultural change. Normally, every company has a centralized planning, and responsibility to the people on the shop floor and a decentralized detailed planning is a cultural change for a lot of companies. And at least the tool, the software, our product, the CC tact-oriented planning is nothing else as a tool that supports this planning methodology. So we have a transparency over everything. We have a robust, feasible, and accepted production plans. Important is that the system only make recommendations, but the man on the shop floor make the final decision. And the goal is to reduce the effort and to focus more on time to solving problems we have. In hard facts, it means if we see the last projects, normally we increase the output by 40%. At the same time, the lead time will be reduced by 50%. The on-time delivery, so that we meet our delivery dates we gave to the customer, increase for over 90% with a better transparency over the whole process. The efficiency will increase by 30% and through to the cultural change with a better communication efficiency in the whole company. Okay, now I'm at the end of this webinar. The goal was to give you a first impression what is possible with the CC tact-based planning and whatnot. If you need some more information, please visit our landing page or our other webinars. All are available in German and English. The next one is Harmony Between Design and Production, November the 5th. Then we have Transparency in Calculation, November the 26th. And of course, Interdepartmental Change Management, November the 28th. For each webinars, we have information on our landing page. And also, you find all the information here on our In Focus page. So I would like to say thank you and have a nice day and a nice weekend. Bye-bye.